Hi everyone, welcome to this tutorial about macroeconomics and macroeconomic policy. Here I will talk about a definition related to the expenditure approach to GDP. Then I will compare the GDP deflator and the consumer price index as two different measures of inflation. And finally, I will talk about different cases where different variables are affected differently due to different circumstances, and we will look at the consequences on the fiscal multiplier. Let's begin with the expenditure approach to GDP. Y, or national income, or GDP, can be decomposed as the sum of all the different expenditures that were made on the territory. Consumption, investment, G refers to government expenditures, X refers to exports, goods that were sold abroad but that were produced domestically, and finally imports, which corresponds to the purchase of goods that were produced somewhere else but that were sold domestically. According to this definition, an increase in imports, so the letter M, would decrease GDP. Think about, for instance, a car that is being imported by an individual. So the car was produced in another country but was sold in that consumer's country. Looking at the definition of GDP, the purchase of this car should decrease GDP. Does it actually make sense? After all, if this corresponds to the purchase of goods that should not be taken into account into GDP, then that should not decrease nor increase GDP. Why, then, according to this definition, will it decrease GDP? It is related to the way consumption and imports are being recorded in national accounts. When a good is being imported, if it's a consumption good, it will actually be considered as consumption. So it will enter the consumption category here. Since it enters consumption, somebody who buys a foreign car then will increase GDP. That purchase will increase GDP. Since this good was not produced domestically, but was produced abroad, then, in principle, it should not increase GDP, nor should it decrease it. Thus, we include minus M at the end to cancel the purchase of foreign goods that initially entered the C category. So instead of looking at this as the purchase of the car only enters here, it actually enters the consumption category. And to remove that purchase, because it should not affect GDP, we actually write minus M. If the car, for instance, costs $30,000, consumption will increase by $30,000. Thus, GDP will increase by $30,000. Since it should not, we then input minus $30,000 in the form of imports, so that these $30,000 entering consumption will cancel out with the minus 30,000 here entered as imports. And at the end of the day, if you buy a good that was produced somewhere else and that was sold domestically, GDP will be unaffected. Thus, it is important to understand exactly how each of these categories are being recorded. Another example is, would a car enter the investment category or the consumption category? After all, a car could be considered an investment. It is typically used for more than a year. It turns out that goods such as cars are actually considered consumption goods, but they enter the category of consumption of durable goods. So the consumption category is divided into two subcategories, durable goods and non-durable goods. Investment then refers to things like productive equipment, housing, and bigger purchases than car. Now, let's get into the measures of inflation. Remember, inflation corresponds to a situation where prices increase. But when I say prices, I remain pretty vague. After all, there are millions of prices in the economy. Even the price of a coffee from the same store might be different for two different locations. So when we refer to inflation, we typically refer to the increase in what we call the consumer price index. It measures the change in the price of a representative basket of goods. We keep this basket constant between two consecutive periods. So, for instance, if oranges are included in the basket, we are going to look at how much of people's budget, of the representative household's budget, oranges represent, let's say 1%. And then we look at the increase in the price of oranges between two periods and multiply it by this 1%. Doing this for all the other prices of all the goods in this basket, we then obtain one single number, which is pretty much an average increase or decrease in the prices of goods. But this average is being weighted by how much each of these goods represent in one's budget. Rent represents a significant portion of most people's monthly budget. So, if rent increases a tiny bit, that would still represent a substantial increase in prices overall because rent takes a big part in consumers' budget. We also went through another measure of the increase or decrease in prices. That was the GDP deflator. We divided nominal GDP by real GDP. So we divided the same quantities for a given year, but we multiply these quantities by different prices. If you look at nominal GDP in 2020, for instance, we will be looking at all the quantities purchased in the economy in 2020 multiplied by their respective prices. However, when we talk about real GDP, we still consider the quantities produced in 2020, but we multiply them by prices of another year. This is what we call the base year. If you've looked at real GDP indicators and graphs over time, you might see as a footnote real GDP expressed in $2005, for instance. So all the GDPs throughout the years, 2006, 2007, and so on, have different quantities, but they are always multiplied by the same prices. This way, between one year and another, the only thing that changes will be the quantities. By dividing nominal GDP by real GDP, since the quantities are the same, we look at the quantities of the same year, but the prices are different. This way, we are looking at a pure increase in prices. The question is, what is the difference between these two measures? First of all, of course, the difference comes from how they are being computed, their formula. But more importantly, the difference is coming from what they represent. The consumer price index represents prices for a representative basket of goods. Some goods do not take any fraction of anyone's budget, or almost no fraction. So these goods will not be counted in the consumer price index. However, since the GDP deflator is a ratio of GDPs, which look at the total quantity of all the goods produced in an economy, then the GDP deflator will cover all possible goods, whereas CPI will restrict itself to goods that have a role in a representative household's budget. So the CPI, for instance, does not take into account investment goods or goods purchased by the government. But the GDP deflator does, because GDP deflator is a ratio of GDPs, and GDPs include C, but also I, G, X, and M in its measure. Well, M are being deducted, so actually the imports are not being counted in the GDP deflator. However, imported goods could be represented inside the representative basket of goods. So the CPI might include the price of some imported goods, which the GDP deflator does not. Another important difference is the fact that the CPI is looking at a fixed basket of goods between two periods. So it ignores what we call substitution effects. If meat represents, let's say, 5% of somebody's budget in a month, but the price of meat increases significantly due to a natural disaster that makes the price of meat rise, for instance, then you can imagine that next month, consumers will not buy that much meat. They might substitute it for maybe other sources of protein, maybe fish, maybe eggs. However, the CPI will keep the fraction of meat in the budget constant between these two periods, as if consumers were still spending 5% of their budget in meat. In this sense, the CPI is not a very accurate measure of the change in prices. If some prices changes, of course the quantities will change. You can imagine as well that the price of bananas will suddenly increase because countries producing bananas experience again a natural disaster. In this case, you can imagine consumers substituting bananas for other fruits like apples or oranges. Suddenly apples will take bananas' fraction of their budget, but the CPI ignore that phenomenon. But when you look at the GDP deflator between two different periods, between these two periods, people will consume or invest in different goods. And if between these two periods the price of bananas suddenly rises, then the consumption of bananas entering the C category in GDP will be lower than in the previous year. And so the price increase in bananas will feel smaller with the GDP deflator than it will feel with the consumer price index. Both measures have advantages and inconvenience. Which measure is better? Like everywhere, there is no one best measure. Typically, by default, we use the consumer price index as a measure for inflation, but we should be more precise and say it's a measure of inflation for goods which are purchased daily by the average consumer. For instance, imagine that rent does not really change, but suddenly the price of houses increases a lot. The GDP deflator will then increase because it includes the purchase of houses in the investment portion. And even though there will be less investment, yes, there will still be some. But if buying a house is not part of the CPI at all, then this increase in prices, in house prices, will not be reflected in the CPI. So you can look at both in practice, but you need to be aware of what they represent and what they do not represent or include. Now, let's do a bit of fiscal policy. So, consider the expenditure approach to GDP again. And let's make the assumption, typical Keynesian assumption, that consumption is equal to the autonomous consumption, what we would consume even without any income, plus a fraction C, between 0 and 1, of households' disposable income. The disposable income is the income net of taxes paid T. Assume now that imports represent a fraction of GDP. So big M will actually be equal to small m times big Y. As if households were importing a certain fraction of their income. You can imagine that this is the case on average every year. Let's see how imports in this case are going to affect the value of the fiscal multiplier. First, we need to compute the fiscal multiplier, and we are going to plug our two assumptions about consumption and about imports. Plugging C here, we get C0 plus little c times y minus t. And plugging m here, we get minus little m y. Y, GDP, appears on both sides of the equation. So let's isolate for y by putting this c times y on the left-hand side and that minus m times y on the left-hand side as well. Finally, to get y alone, divide the right-hand side by whatever is left here, and you get 1 over 1 minus c plus m times c0 minus little c times t plus investment I plus government expenditure G plus exports X. Remember, this value here is what we call the fiscal or spending multiplier. The value of the multiplier now is 1 over 1 minus c plus m. This m has been added to the initial value of the multiplier. Imagine that the government decides to increase G, government expenditure. Then, according to this equation, Y will increase by this amount times the change in government expenditure. We are assuming that everything else is constant, so nothing else will change. Note that when little m is high, this whole number at the bottom of the fraction is higher. And since it's a number at the bottom of a fraction, the fraction itself will get smaller. The multiplier will be smaller the bigger the marginal propensity to import m. Here is the intuition. A government stimulus should in principle stimulate consumption thanks to little c. However, if households instead decide to buy goods that were produced abroad and not domestically, then that will have less impact on GDP. In fact, it will just not increase domestic production. If the government gives me $10 today and I decide to spend these $10 buying something produced somewhere else from Amazon, then Canadians' GDP will not change at all. Unless the increase in the government expenditure is going to affect consumption of domestically produced goods, there will be no impact on GDP. The same way I could actually be saving instead of spending this money. the government gives me some money and I'm maybe worried about the future. So I decide to save a bit more money than usual. So C would get smaller. Since this money is not being used, is not being spent, then I cannot trigger these waves of expenditures, and that will not affect GDP. Savings and imports can be called a leak when we talk about the fiscal multiplier. Let's go back now to a general import function, and let's look at an increase in government expenditure G. However, governments, like everybody else, have budgets. So if they decide to spend extra money, they need to somehow fund this expenditure and maybe repay a loan. So the government might need to pay for that temporary deficit by raising taxes. Can the government pay back for that expenditure by taxing the income while increasing GDP at the same time? On one hand, the government will spend money, but on the other hand, the government will take more money back from consumers by increasing T. So if the government increases G by delta G, it will have to increase taxes by the same amount in order to keep the budget balanced. Looking at the value of the multiplier here, and looking at the fact that both G and T are going to change, then we can plug here delta G, here delta T, which is also equal to delta G, and we end up with a change in GDP of this much. Note that there is a minus C on taxes due to the original consumption function. Well, it turns out that if you isolate for delta G, you factorize, inside of these brackets you're going to get 1 minus C. And this 1 minus C is going to cancel out with this 1 minus C at the bottom. At the end of the day, the economy will still grow, but instead of growing more than proportionally to the increase in G, like with the fiscal multiplier, it will increase by exactly the same amount. It will increase by the same amount. On one hand, the budget is balanced because the government managed to spend money and get this money back. No problem. And at the same time, GDP grew by an amount delta G. This result is known as Havamo Theorem, after Trygve Magnus Havamo, a Norwegian economist, so I'm probably butchering his name, I apologize, where he tweaked the value of the multiplier and he called this the fiscal multiplier, the balanced budget fiscal multiplier, which here is equal to just 1. But at the same time, it allowed the government to balance its budgets and not run into massive amounts of debts. Now, you might be wondering, so that looks great. Why don't governments do this? Well, it still relies on this assumption, which might change according to circumstances. If consumers expect the future to be bright, they might actually have a higher little c. They might consume more of their money because they are not worried too much about the future. But if, on the other hand, they think that future is very uncertain, they might lose their job, or they fear that there's going to be a lot of inflation and so on, they might actually prefer to save more of their money and they will consume less. That in principle should not make a big difference, but it all depends on what this C is. And here, GDP is only increasing because the government is spending more money at the end of the day. So that's not particularly interesting for firms if they are thinking about an increase in future demand, which means hiring more. Hiring more means more income. More income means more consumption. If firms know that this increase in GDP is purely artificial and comes from a sudden increase in government expenditure, which might not happen every period, then firms might not be very enthusiastic at the idea of increasing the scale of their productions and at the idea of hiring. Assume a random shock affects financial markets. This shock, whatever it is, results in a decrease in the interest rate. How will that affect GDP using the expenditure approach from above? First of all, we need to understand where the interest rate appears in this equation. Interest rate is going to affect investment most likely. When interest rates are low, households might be more interested into buying a house, or firms might be more interested into increasing the scale of their production by investing in production capacities. If the interest rate decreases, we will see most likely an increase in investment. And if everything else is kept constant, then you can imagine that I will increase by delta I. And again, using the fiscal multiplier, we will get a proportional increase in GDP. But this proportion will be more than 1. It will be more than 1 to 1. And it is always interesting to think about these little shocks that could affect other markets and see how they can affect the main aggregate variables. Here I make a very simple assumption that only financial markets are affected by this shock. But very often, since markets are connected to each other, an increase in the interest rate might actually have ripple effects on other markets and therefore affecting other variables. For instance, changes in the interest rate might actually have an impact on the exchange rate. The exchange rate will definitely have an impact on X and M. So not only I will change in this case, but also exports and imports. But it is always interesting to just think about what could happen if. Taking into account maybe a very isolated shock versus a shock that is going to propagate across markets. Let's turn now to an economy where people are pessimistic. They might not be very confident towards the future. There could be tensions in terms of diplomatic relationships. There could be maybe the expectation of a war coming, or there could be something about they fear that financial markets are going to crash, and so on and so forth. Overall, just imagine a case where people are more pessimistic. Due to this mood, then let's make the assumption that consumption will still be equal to autonomous consumption C0, but now the marginal propensity to consume will actually switch to C prime instead of C. And C prime is smaller than C. If you think the future is very uncertain, most likely you're going to save a bit more money, which means consume less. in order to protect yourself against future risks. In such a situation, will a government stimulus have a larger or smaller impact than under regular circumstances? Well, let's go back to the fiscal multiplier again. Since C prime is lower than C, then we have that 1 minus C prime is bigger than 1 minus C. And when you take the inverse to get the value of the fiscal multiplier, you will get that 1 over 1 minus C prime is lower than 1 over 1 minus C. C prime is smaller here, so the bottom is larger, so the whole fraction is smaller. We will still get a proportional increase in GDP after an increase in government spending, but that increase will not be as big as if consumers are more optimistic. Remember that savings constitute a leak in the multiplier model. So if households decide to save more money because they fear for the future, it will reduce the magnitude of the effects of an increase in G. Why? Because each wave of spending will now be smaller. If you fear about the future and I give you $10, instead of consuming $8 today, you might decide to only consume $5, and you're going to keep $5 at the bank. Once you spend these $5, that will only increase the income of whoever you're buying from by $5. And out of these $5, these other individuals will consume only 50% of their income instead of 80%. So they'll only consume $2.5. In the next wave, half of $2.5 will give you $1.25. And these waves are actually going to die down faster than if the marginal propensity to consume is higher. It is one of the reasons why fiscal policies, as interesting as they look on the paper, on theory, are tools that governments have to carry in a very cautious way. They might spend money that might increase G and not see an increase in GDP because maybe individuals will respond by importing more or by saving more. And that will be money spent by the government, which will not help to stimulate the economy. A perfect example was the French economy in 1982. In 1981, there was a new French president. He was a left-wing president that came in power after a long streak of right-wing presidents. The beginning of the 80s was particularly difficult for many European countries because there was an oil shock in 1978 and 1979, leading to an increase in gas prices, in oil prices as well. The French government, with this fresh president, decided to stimulate the economy by increasing G, hoping that French individuals would consume more and reinstore this cycle of confidence where firms expect production to increase, so they hire. By hiring, income increases, and so on and so forth. What French people ended up doing, however, is buy house equipment like microwaves, televisions, dishwashers, and so on, which were produced in Asia. So this extra income was not used for goods produced domestically, but rather for goods produced abroad. That stimulus was not effective at all at the end of the day. that's it for this tutorial about macroeconomic policy. This is really just the basics of the theories. Remember that macroeconomics is way more complicated than this, and there have been many other theories and refinements of the fiscal multiplier model. Have a good rest of your week, and see you in the next one. Bye.